Here's the next example. So we have tension is the force experienced in a taut rope or cord or wire, etc. So we have a shopping bag is lifted upwards by its handles. So I don't know if you've ever had to carry a heavy bag of shopping groceries before, but sometimes you'll notice that the handles actually rip. And that usually happens when you jerk the bag upwards, like with you trying to lift up a heavy bag and you pull it upwards, that is when it rips. Because you actually the tension in the rope is actually greatest when you try to accelerate upwards. It's actually just like the elevator question. When you accelerate upwards in the elevator, you feel a greater normal force. When you accelerate downwards, it's less than. So the same idea with the shopping bag. So if I were to draw this, we have a shopping bag, and I'm going to use the symbol T because we're talking about tension, and then there's some force of gravity. We're saying we're accelerating this thing upwards at 1.2 meters per second squared. So that's why my T force is drawn bigger than the force of gravity. I know that my unbalanced force is in the upwards direction. So I go F net is equal to MA. It's equal to the sum of all the individual forces. So in this case, we have MA. It's the tension force upwards, the force you're pulling it with, minus that force of gravity. So for us to accelerate this thing upwards, we have to first overcome gravity, and then we have to apply a bit more force, is what it's saying. So we're looking for tension. So T is equal to MA plus force of gravity. We move the FG over. So you can rewrite this as MA plus G, because MA plus MG. We can just factor the M if we want, simplify it down. So we have that 1.2 meters per second squared plus the 9.8 gets us a value multiplied by our mass. We get 39 newtons of force. So the overall force now must be exerted upwards in that rope. Must be 39 newtons to lift this particular bag of groceries. Now in reality, when we have a shopping bag, usually there are those 4 straps. 1, 2, 3, 4 straps. So if we actually were to draw a more realistic diagram, there's 1, 2, 3, 4 T values, force of gravity. So our equation would change to MA is equal to 4T minus FG. So when we find this out, we have 4T is equal to MA plus G. So in other words, all we're going to do is divide that 39 newtons by 4 to find out how much force each individual rope is going to experience. Usually what happens is like if you accidentally pick up a bag just by one handle, it means it's distributing all that force along 2 joints. So that means each thing would experience like around 19 newtons of force. So that's why the more ropes you have attached to it, you can distribute that force. Next one says, if each of the 4 straps can withstand a maximum tension of 12 newtons, with what maximum acceleration can the bag? So just like the first part of that question, but in the opposite direction. So if each one can do 12 newtons, that means the overall upward force being exerted with is going to be 4 times that number. So it's going to be 48 newtons. Okay, so we're going to write down MA is equal to tension minus force of gravity. And we know that MA is equal to T minus mg. So we get 3.5 kilograms times A is equal to 48 newtons minus 3.5 kilograms minus 9.81. So plug this all in, we get A is equal to 3.1 meters per second squared.